Hello guys, Winston here. I am finally able to talk about the project that took over my life in January. Late last year, I was approached by DD Audio, an Oklahoma-based company with a strong presence in car audio among other segments. Last year, they decided they wanted to recognize high-performing dealers in their distribution network, and so they made some plaques on a laser cutter to hand out. This year, they wanted something a little different, and so they approached me to come up with a new award for the 2017 calendar year. They gave me pretty broad creative freedom with the design, so I began by sketching up some ideas. In my mind, by choosing someone like me, the company wanted something that only a CNC could make, otherwise they would have just done it themselves. So that meant incorporating 3D contours into my design. Since these awards have become something of an annual tradition, I had a couple constraints. The award plaques should be roughly the same size as the previous years, so 8 by 10 inches, and they should also follow a similar form factor, so I needed some sort of speaker-related thing to integrate centrally. My idea was to create the tapered profile of a speaker cone as the dominant feature. That would be visually interesting from off-center angles. I mocked up something quickly in Fusion 360 and sent it off to the company for them to ponder. They came back to me with some interesting guidance. First off was to get rid of the OGs on the border. That was a little too formal and it didn't have the aesthetic they were looking for. Second, they suggested I take a bit of a mid-century modern tack with inspiration from figures like Lloyd Wright. This bewildered me as A, I'd never really tried to fit a certain theme before, and B, I didn't really know what mid-century modern was all about. I've seen plenty of YouTube woodworkers making mid-century modern bookcases and nightstands and tables, but I've never seen a formal definition of what mid-century modern was. My Wikipedia research led me to a couple basic design tenets. Simplicity is good, don't let the aesthetics of the material get drowned out by excessive design, be more organic and less formal. Great. These are all ideologies that sound elegant as an artist, but terrify me as an engineer. I still wasn't sure how I was going to manage to merge those ideas with my award. So I did a little more searching on Pinterest and Google, and when I searched mid-century modern plaque, I came across these address numbers. They all have a similar style, with the numbers either standing out in positive or negative space, in stark contrast to their backgrounds. And I seized upon that one idea of using simplicity to highlight a centerpiece as the basis for my award design. I would strip away as much of the plaque as I could, leaving only the bare essentials: a frame, a nameplate, and my CNC'd speaker model. The nameplates were the ones that I'd showed off in my last video. These pieces would be anchored on an acrylic sheet. I made a new CAD model, got a green light from the company, and made a prototype to show. With a firm commitment from DD Audio and a down payment to cover the cost of materials, I got ready to begin mass production of 24 awards. The first step was to source my wood. Since national brand hardware stores have a god-awful selection of hardwoods, I went off to Willard Brothers Woodcutters near Trenton to purchase 20 or 30 board feet of oak. The stock I ended up with was surfaced on two sides, so it was less than an inch thick, but it was way more generous than the 1x boards at Lowe's, which are closer to 3/4 inch than 1 inch. These were only about a 1/16 under a full inch. Unfortunately, my design called for 3/4 inch material, so I'd have to bring it down to that thickness anyway. At least by doing it myself, I could ensure that all of my boards were super consistent. The fastest way to remove material from boards is to plane them, and luckily my uncle had loaned me a thickness planer a couple months back. Problem was, he had lost the safety key and didn't know where it was. No matter, I would make my own. Then I discovered another problem in that I had no dust collection port. This planer would just spew sawdust out into my garage until my furnace ignited and I blew up my house. So I fixed that as well. Then I got to planing. I steadily worked my way down about a 32nd of an inch at a time. It took me about 30% longer than usual because I was overwhelming my dust collection system. These Home Depot buckets just aren't big enough for heavy-duty use. I filled 3 or 4 trash bags with sawdust, but in the end I had boards that were within about 1/6 of 3/4 of an inch. This consistency is really important in mass production, as I found out in a previous unnamed project involving drink coasters. Once my boards were thinned down, I cut them into more manageable lengths. I didn't do this earlier because I wanted to minimize the amount of material that was subjected to snipe. Moving on to my shape boko, I had to orient each board in the Y direction. I wanted to cut 2 plaques from each board to minimize the amount of wasted margin around the frames, and because of the size of my stock shape boko, this meant that I'd be cutting 1 frame at a time. This wasn't a problem as long as I had a way to quickly index my stock in a suitable starting position each time. Once I had my work holding figured out, I started cutting out my plaques. Because of how I would be finishing my pieces, I wasn't afraid to make prodigious use of tabs to keep everything in place. This let me cut my speaker blank and my frame from the same section of material. However, as I was cutting, I noticed places where I could improve my process. For starters, I was seeing tiny indents where my end mill was retracting for tabs. I'm pretty sure this isn't runout but actually deflection, more on that in a future video, but I improved my surface finish by switching to trapezoidal tabs and running a finishing pass on all my walls. I also noticed that the outer walls of my excess stock had a nicer finish than the inside walls of the parts I wanted to keep. There's no hard and fast guideline in wood for which direction you should cut, climb, or conventional, but if you notice that the walls of the side you want to keep aren't as nice as the side you plan on discarding, don't be afraid to reverse direction. I ended up switching my finishing pass from climb to conventional cutting. And lastly, I was getting tired of long fibers of oak pulling out of my cuts and clogging my underpowered and undersized dust collection. I know my 1 1/4 inch hose is quite small, but it's never clogged like this before. I use it because it's flexible and puts no load on the Shapeoko. In this instance, it was becoming something of a liability. So I studied the behavior of oak as it was being cut, and I hypothesized that long cuts with the grain of the wood were the problem. I never had fibers pulling out when I was cutting against the grain. I decided to switch the pocketing operation that I was doing from my plexiglass backplane to an adaptive clear. The tricoidal tool pathing that it used for my recessed track maximized the amount of time that I was cutting against the grain. Even though it looks slower, because I'm cutting deeper, the impact on material removal rate isn't as bad as you think. After this change, I felt a lot better about leaving my Shapeoko unattended for longer periods of time. These continuous improvements in my process are things that you just can't tease out when you're making 1 or 2 of something. They happen over time and through iteration. These learning moments are what I find most rewarding when I'm doing mass production of something. At a couple points, I brought my Shapeoko XL to bear on the project, but only during the weekends when I could machine during daylight hours. Otherwise, I leaned more heavily on my stock Shapeoko 3 because it was enclosed. I'd knock out a couple frames each night after work. Once I had about 26 or 27 frames machined out, I went to my DIY router table to trim off the tabs. You'll notice that I'm not using a flush trim bit, but instead going straight to the chamfer cutter. I knew that if I'd picked tabs that were short enough, I could get away with this. I also knew that because of how I'd be cutting my speaker blanks, that a chamfer on the backside would be machined off anyway. This saved me from having to switch out router bits, which honestly wasn't a big deal, but little things like that really help my mental flow. Having to stop my process to change a bit or pick up a different tool is sometimes frustrating for me when I have to do it multiple times. And that's also why I designed my first CNC operation to only use a 1/4 inch end mill. But eventually I had to face the reality that certain features like the engraving on my fake speakers required the use of other end mills to complete. So to minimize tool changes here, I would engrave as many speakers at a time as possible. I devised a jig that would use pins to index 4 blanks at a time. I'd first engrave the batch with a V-bit, then switch to an 1/8 inch downcutting end mill to true up the diameter and clean up as much of the fuzz as possible. When I swapped out the cut blanks for a new set, I'd then start with the 1/8 inch and finish with the V-bit. This kept the necessary tool changes to basically 1 per batch. On the flip side, I would use a 1/4 inch downcutting end mill to carve out the cone shape of the speaker. The design of this shape had evolved a little from my original prototype for reasons of practicality. The steeper angle not only means that the taper is more visible from the side, but it also reduced the volume of material that I would need to remove. My cycle time went from 30 minutes per speaker to 20 minutes. That may not sound like much, but 10 minutes times 24 speakers is 4 hours of machining. And in the interests of transparency, when I was pricing these out for my client, 20 minutes was my actual estimate for this step, so any longer and I'd be earning a lower hourly rate than I planned. I know some of you guys have asked me about how to price your work, and honestly, I don't have a great answer. There's a lot of subjective factors that go into that calculation, and I'll discuss mine in another video on my second channel, but I will say I gave David Picciuto's advice in Creators Collective podcast number 39 a lot of thought. Since I was using a downcutting end mill here, I felt confident that a little double-sided tape in conjunction with my pins would be more than enough to keep my blanks from being knocked loose. I did some hand sanding to clean up my frames and speakers and moved on to finishing. For this step, I chose a water-based polyurethane because it dries with a little less odor, and I was doing this in an enclosed space. Plus, it builds thickness faster than spray poly, not that spray poly was even feasible here. The temperatures outside are in the upper 20s, lower 30s this time of year. I wore a respirator for this step just because ventilation was not an option. Again, with a theme of continuous improvement, I got faster and more comfortable applying finish as time went on. I learned where to hold my piece, what faces to finish first, and how to choose my brush technique to minimize drips and runs. You can see here just how much my pace improved over a couple iterations. To get everything done in one go and allow myself to finish both sides of my plaque at once, I needed to be able to rest the frames off the table while they dried. Fortunately, I realized that my scraps from machining were perfect for acting as painter's standoffs, and I could use bolts to hold my speakers and elevate them off the table. In parallel with this effort, I needed to figure out how I was going to cut my acrylic backplanes. As it turns out, I have a friend with a new Glowforge, and this would be a great excuse to try it out. So I persuaded him to let me come over and we got to work cutting my box of acrylic. First, we cut them down to a size that would fit in the Glowforge nicely while minimizing waste. Then we fired up the laser and dialed in our cutting parameters. Glowforge has recommended parameters for 1/4 inch and 1/8 inch acrylic, so we interpolated to find a suitable speed for 3/16 inch acrylic. After that, it only took a couple minutes to knock out each set of backplanes. Having a laser is super handy, and I'm kinda regretful I didn't similarly pull the trigger when this thing was in Kickstarter phase, even though Glowforge has had some growing pains I'll touch on in a future laser project. Now for my plaque project, I needed to tap these acrylic sheets so I could bolt on the nameplates and wooden speaker. The fastest way to do that was with a power drill. My 1024 threads that would secure my nameplates were a little trickier to do than the 1/420 threads for the speakers. The chip clearing on my smaller tap just wasn't as good, but with my drill set to its low speed range and a little cleaning between holes, I managed to get all my backplanes tapped in record time. This was honestly one of the more low stress operations in this project. Once my oak pieces were dry, I had to go back with some really fine sandpaper to knock down the grain that had been raised. To put my name on the backs of these awards, I quickly branded the body of my oak speakers. Before I integrated everything, I needed to drill some pilot holes for my hangers. These metal clips are held in place by a pair of small nails that are really hard to hold straight and really easy to bend, a terrible combination. So I decided to drill some pilot holes to make my life easier. But before I could do that, I needed to spot drill my speakers since it's really easy for a number 56 drill to wander off course, especially when valleys in the grain are so large relative to the bit. I stuck a V-bit in my Shapeoko and set up a quick little operation to poke 2 little divots into my speakers. I didn't even bother to use tape or anything to secure my pieces because the cutting forces would be so low. My setup using locating pins was definitely the MVP of this project. Then I drilled my holes, nailed in my hangers, and prepared for final integration. Step 1 was to glue in the backplanes to the frame. A few strategically located dabs of E6000 were all it took. Again, I'm using the respirator here because of the lack of ventilation. One tricky thing here was that my acrylic was slightly recessed, so in order to apply clamping pressure between it and the frame, I had to use some sort of intermediate spacer. Stacking my frames like this was a lot more space efficient, and I didn't need to find as many heavy objects to use to apply weight. After 24 hours, I began integrating my speakers. These pieces were first bolted to my acrylic using 3/4 inch bolts. In cases where I had a little too much stick out of the threads, I added a washer. Then I glued on carbon fiber dust caps that DD Audio had sent me. These were also done with E6000. I have a love-hate relationship with this stuff, but for bonding materials to wood, where I need a thick bead and flexibility, it can't be beat. I did have one complication during this step, which was that the dust caps weren't perfectly flat. Their circumference had a slight saddle shape. I thought it would be enough to just let my plaques cure upside down, but the plaque itself wasn't heavy enough to flatten out the dust cap. I panicked for a bit trying to figure out how I would apply weight to a curved surface before running inside the house to grab every single roll of tape I could find. The circular profile of tape rolls, which almost universally have a 3-inch diameter, allowed me to stack my plaques and apply weight just like I did the day before. I had exactly the number of tape rolls needed to pull this off. After another 12 hours, I came back and bolted on my nameplates. These would stand proud of the acrylic by way of these 1/4 inch aluminum spacers. Unfortunately, I realized that when I'd drawn these models, I'd used the tap hole diameter for everything. The nameplates needed through holes, so I had to really carefully drill them out to a larger diameter. Then I bolted my nameplates to the plaque and went to work. Oh yeah, did I mention that I'd woken up at 4:30 AM to get these done? A couple hours later, I came home during my lunch break to pack everything up for shipping. I'd originally conceived of packing these up by snaking bubble wrap in an S shape between a bunch of plaques, but I found that to be quite awkward. I ended up wrapping 2 plaques at once and boxing them up that way. Next, I filled up any remaining space in my box with paper and cocooned my box in packing tape. Then I went to work, snuck out a couple minutes early so I could drop off the package at the post office before it closed, and went home to crack open a cold one. DD Audio received delivery of my plaques 2 days later and put on the finishing touches, their award logo on the dust cap. Then they shipped them out to the winners. This project was definitely less stressful than my aluminum coaster project last year, but still quite complex because of all the different parts I needed to sync up. And that finally wraps up this project video. I want to thank you all very much for watching, and I'll hopefully be back on a more regular video release schedule now that this project is 100% out of my hair. See you in a week or two. Then I glued on carbon fiber dust caps that DD Audio had sent me. Oh my god, can you hear the geese outside?